Hello students, so today I am going to start a new chapter which is chapter 8, more on MySQL, and the topic that I shall be discussing now will be data integrity. So first of all, what do you mean by data integrity? Now we all know that a database is a huge repository of data. Large amounts of data can be stored inside a database, and all those data get stored in tabular format inside a database. There can be many tables inside a database, and it is the tables which stores data in the form of rows and columns inside a database. Now if such huge amount of data gets stored inside a database, we have to ensure that the data that gets stored is always correct and consistent, and that is what we call as data integrity. So data integrity refers to the correctness and consistency of data stored in a database. If we can't maintain integrity of data inside a database, we will see different types of anomalies or errors coming out of such databases. That's why data integrity is a necessary step towards storing the correct and the consistent data inside a database. MySQL database stores huge quantity of data in the form of tables. And if we want the MySQL database to be free from errors or anomalies, we must see to it that the data integrity is maintained. The data stored in these tables can be accessed, modified, or even deleted by the client applications. Hence, there should be measures so that only the valid data can be inserted. And after each insert, update, or delete operations, data in the database is correct and consistent. Now data integrity is classified into three types. The first one is the entity integrity, the second one is the referential integrity, and the third one is the domain integrity. Let's start with the entity integrity. Entity integrity defines that each row or record in a table must be unique. Now let me explain you entity integrity with the help of an example. Look at these two tables. The first table is identified by the name Dr. 1 and the second table is identified by the name Dr. 2. If you see the first table Dr. 1, two of the rows are redundant. Now please note that redundancy means duplication. These two rows are being repeated in this table Dr. 1. So we can now say that the table Dr. 1 consists of redundant rows or duplicate rows. Now if we have to see from the perspective of entity integrity, no, entity integrity is not maintained in this table Dr. 1. And that is due to the fact that the rows in this table are not unique. So as the row 23 dental has been repeated, there is no entity integrity in this table. Such duplicate rows will make the table inconsistent. There can be different types of errors or anomalies that may arise out from this table. And if a database administrator tries to operate on such type of redundant tables, he will have a difficult time fixing such errors. So the best thing that we can do is to avoid inserting duplicate rows like this. Instead, try to make a table of this format, that is like the table Dr. 2. If you look at this table, all its rows are unique. There is no repetition. The row 22 ENT is occurring only once. The row 23 dental is also occurring only once. and the row 24 oncologist is also occurring only once. So we can say that there are no duplicate rows in this table Dr. 2. So the data inside this table is consistent, and that's the reason this table maintains entity integrity. The entity integrity can be maintained by defining a primary key or a unique key on one or more columns of a table. Now if you look at this table Dr. 2, the column DEP code has all its entries unique. The entry 22, 23 and 24 is occurring only once. So we can say that the column DEP code is a primary key column for this table named Dr. 2. Since it's a primary key column, so this column can uniquely identify every row or every record in the table Dr. 2. The column DEP code with the entry 22 uniquely identifies the first row, that is this one. Similarly, the entry 23 for DEP code, the entry 23 for DEP code uniquely identifies the second record, that is this one. And then the entry 24 for DEP code uniquely identifies the third record, that is this one. In this way, the primary key column DEP code uniquely identifies every record in the table Dr. 2. And it is due to this fact that the table Dr. 2 maintains entity integrity. But if you look at the same DEP code column in this table, that is Dr. 1, its entries are not unique. This is because the entry 23 is repeated, and due to this redundancy, the column DEP code is not the primary key column for the table Dr. 1. And it is for this reason that this particular table Dr. 1 does not maintain entity integrity. Now let's discuss about the next type of integrity known as the domain integrity. The domain integrity ensures that a column in a table should accept only a valid range of values or any value from a set of defined values. That means there will be a domain which shall consist of a set of acceptable values for a column inside a table to choose. Any values outside of the domain shall not be acceptable and will be invalid for that column. Let's take an example. If we are going to store the marital status of an employee in the marital status column of the employee table, it should accept the values from a defined list of values like married, single, widow or divorced. Now note that the marital status that I am referring to now is a column belonging to the table named employee. That's why I am highlighting it like this. Just consider the table name to be employee, and inside this table there exists a column named marital status. Now this column marital status has a domain to choose a possible list of values, and the domain consists of these values, that is married, single, widow or divorced. So this column marital status can only take these entries from the domain. Any other entries outside of these four shall not be acceptable for the column marital status. Now domain integrity can be maintained for a column in a table using the enum constraint and the set constraint. Now consider this particular example in this slide. A table identified by the name person has been created using this create table command. This table has 4 different columns. The first column is person ID, that is this one. The second column is person name, that is this one. The third column is gender, which is this one, and the fourth column is marital status, which is this one. Now see the column declaration of gender. The enum constraint has been imposed on this column named gender, and its domain consists of the values male and female. Any values outside of this domain shall not be acceptable for this column gender. Again, look at the column declaration marital status. The set constraint has been imposed on this column marital status, and the domain consists of 4 different values, which are single, married, widow and divorced. That means only these 4 values can be chosen for the column marital status. Any value which is outside of this domain cannot be chosen for this column marital status. Now let's say I want to insert a record into the person table with these values, that is 1 for person ID, RAM for person name, male for gender and single for marital status. Now will this be acceptable? So 1 for person ID, it will be acceptable because 1 is an integer. Again, RAM for person name is also acceptable because RAM consists of a group of characters for which the data type varchar is already mentioned. Then look at male. Male is an entry belonging to the column gender, which has been imposed the enum constraint with the domain consisting these 2 values, male and female. Now since the value male belongs to this domain, so this is acceptable. Then the fourth value single belongs to the column marital status, which has been imposed the set constraint with these 4 values, that is single, married, widow and divorced. Now as single chosen here belongs to this domain, so this is an acceptable value. As a result, the insert statement trying to insert these values into the table proves to be correct, and that's the reason I can see these entries getting displayed in the output table like this. And that's why we can now conclude that this insert statement maintains domain integrity while inserting this record with the values 1, RAM, male and single. Now look at the next insert statement below. Okay, look at this one. This insert statement, it tries to insert these values, that is 2, Tina, female and unmarried. If you look here, these 3 entries are acceptable, okay, because 2 is an entry, okay, for the column person ID, which is obviously an integer value. Again, Tina is an entry for the column person name. As Tina consists of a group of characters, the varchar data type for the column person name will accept that. Then look at the third entry, female. Okay, this entry is for the gender column. Okay, again this gender column has been imposed the enum constraint, okay, which I have already discussed, and then it is having a domain consisting of only these 2 values, that is male and female. Now since the entry female belongs to that domain, that is, since this entry female is inside this domain consisting of male and female, so this is an acceptable value or an entry for the gender column. Then look at the fourth entry, unmarried. Okay, this entry belongs to the column marital status, which has been imposed the set constraint. The domain for this consists of these four values: single, married, widow, and divorced. Okay, now if you look at this entry, unmarried, okay, is this entry inside this domain? No, the entry unmarried is not inside this domain. Okay, it is outside of this domain, because the domain has only these four entries, which are single, married, widow, and divorced. And that's the reason the entry unmarried will not be acceptable for the column marital status. As a result, this insert command, which tries to insert this record to Tina, female and unmarried, proves to be wrong, due to the fact that this insert statement does not maintain domain integrity after it tried to insert this fourth entry, unmarried, for the column named marital status. Now all this time I have been talking about domain integrity imposed on the columns gender and marital status through the enum and the set constraint. Now can you guess what's the difference between the enum constraint and the set constraint? We now know that these are the constraints through which we can impose domain integrity on a column of a table. Here in this table named person, I have used the enum constraint to impose domain integrity for the column gender, and then I have used the set constraint to impose domain integrity for the column marital status. Now let me show you the difference between these two. If you apply the enum constraint on the column gender with the domain consisting of the values male and female, then only one value out of male or female can be chosen for the column named gender. In this case, I have chosen the value female for gender as indicated by the color red. Now if I choose the set constraint with the domain single, married, widow and divorced to be imposed on the column marital status, then I can choose multiple values out of single, married, widow and divorced for our column named marital status. In this case, I have chosen two values, that is single and married, for the column named marital status. So now I guess you understood the difference between the enum constraint and the set constraint. So keep in mind that when you use the enum constraint having only these two values in the domain, then you can choose only one possible value out of this domain. You cannot select multiple values. That's why I have chosen only the value female from inside this domain. If I wish to select both these values, that is male and female, out here, that is not possible because the enum constraint doesn't allow us to select multiple values from the domain. But if we use the set constraint, it is possible to select multiple values out of its domain, and it is clearly indicated here. Okay, with the help of the set constraint, I am able to choose multiple values such as single and married both for the column named marital status. Okay, if I want to choose widow, I can tick here at widow, and also if I want to choose divorce, I can tick here at divorce. So the set constraint gives us and allow us to choose multiple entries from the domain. Now the third type of data integrity is the referential integrity. Before I start with this topic called referential integrity, you should know what a foreign key is. So what's a foreign key? A foreign key is a column or a group of columns in a relational database table that provides a link between data in two tables. So we can now say that a foreign key is a column in a table that can be used to link two different tables. The foreign key will act as a cross-reference between the two tables, because the foreign key in one table shall reference the primary key of another table, thereby establishing a link between them. So it is the foreign key in a particular table which, when references the primary key of another table, will establish a link or a connection between those two tables. Now let me make you understand the concept of foreign key with the help of these two tables. Now if you look at this particular table identified by the name doctor, the column name DOC code is the primary key column, as all its entries are distinct. So this column DOC code can uniquely identify every record for this table named doctor. Again, if you look at this particular table identified by the name department, here DEP code is the primary key column because all its entries are distinct. So in the table doctor, DOC code is the primary key column, and in the table department, DEP code is the primary key column. But here if you look at this column named DEP code, which exists as a primary key column for the table department, also exists in another table known as doctor, but not as a primary key, as the primary key for this table is DOC code. So DEP code is the primary key only for this table, that is department, but it is not the primary key for the table doctor, but it is existing in this table named doctor just to help make a link or a connection between these two tables, that is doctor and department. So DEP code, which exists in this table doctor but not as a primary key, will help make a connection between both these tables by linking with the same primary key DEP code in the department table. So we can now say that in this table doctor, DEP code will act as the foreign key. So here the foreign key DEP code for this table doctor will make a reference or a link with the primary key column DEP code of the department table to help make a connection between both these tables, that is doctor and department. So it is now clear from here that both these tables doctor and department are connected with the help of one particular column, that is DEP code. The DEP code, which is the foreign key column in the doctor table, references with the DEP code, which is the primary key column in the department table, and this reference creates a link or a connection between both these tables. Now another thing to be noted here is that the table which consists of the foreign key is known as the child table. That's why if you look here, the table doctor, which consists of the foreign key column DEP code, will become the child table, and the table which does not contain the foreign key will become the parent table. If you look at here, the table department does not contain the foreign key, it only has a primary key. So here this table department acts as the parent table. So to now sum it up, the foreign key is a column in a particular table which references or make a connection with the primary key of another table to link both the tables. So here the foreign key column DEP code in the doctor table references or connects with the primary key column DEP code of the department column of the department table, and due to that both these tables, doctor and department, gets connected or linked. Now since you are clear with the concept of foreign key, I shall be discussing now the topic known as referential integrity. Referential integrity ensures that the data of column of a table is related to the data of any other column of same or other table using the parent and child relationship. Any modification in the data of the parent table should reflect in the child table. Now let me explain referential integrity with the help of these two tables, that is the table doctor and the table department. The table department has a primary key column known as DEP code, whereas the table doctor has the primary key column known as DOC code. Now in addition to the primary key column known as DOC code, the table doctor also has DEP code acting as a column, which is actually the primary key column for the table department. So in this case here DEP code for this table doctor will act as the foreign key column, and this foreign key column will help relate or connect both these tables doctor and department through a reference. So the foreign key column DEP code in the child table doctor will try to reference with the DEP code column, which is the primary key column of the table department. And when it does that, that is when it tries to create a reference from the foreign key of the table doctor into the primary key of the table department, not all the values for the DEP code column acting as the foreign key in the doctor table can be referenced with the DEP code column acting as the primary key in the department table. Now if you see here, the value 22 for the foreign key column DEP code in the doctor table exists in the primary key column DEP code of the department table. So there is a connection through the value 22 for the DEP code column from the doctor table into the department table. So both these tables gets connected with the help of the value 22 for the DEP code column. But if we look at the value 24 for the DEP code column, which is acting as the foreign key in the doctor table, there is no matching value of 24 for the primary key column DEP code in the department table. So now both these tables fail to get linked or connected for the value 24 of the DEP code column. There is a matching value between both these tables only when the value is 22. But when the value is 24 for the DEP code column in the doctor table, there is no matching value of 24 that exists in the DEP code column of the department table. As a result, both these tables fail to get connected with the value 24 for DEP code, and due to which both these tables, that is doctor and department, do not maintain referential integrity. Note that the table which consists of the foreign key is the child table, and the table which do not consist of the foreign key is the parent table. To create a link or a reference between both these tables, all the entries under the foreign key column of the child table must be present under the primary key column of the parent table. But in this case, it didn't happen, as the entry 24 for the foreign key column DEP code of the child table doctor is not present under the primary key column DEP code of the parent table department, and that breaks the referential integrity between both the tables. Now look at this particular slide. Okay, I have modified the table doctor, okay, the child table doctor, which consists of the foreign key column DEP code. I have modified the child table doctor in such a way that I have changed the value from 24 to 23. Now if you see here, the value 22 belonging to the foreign key column DEP code of the child table doctor also exists under the primary key column DEP code of the parent table department. So this creates a reference or a link between both these tables through the value 22. Again, if we look here, for the value 23 under the foreign key column DEP code of the child table doctor, there is a matching value of 23 under the primary key column DEP code of the parent table department. So again, both these tables are getting connected through the value 23. As a result, for all the values for the foreign key column DEP code in the child table doctor, there is a match in the primary key column DEP code of the parent table department. So both these tables gets connected for all its values under the foreign key column DEP code. There is no such value under the foreign key column DEP code of the child table doctor which is not present under the primary key column DEP code of the department table. The value 22 matches with the primary key column DEP code of the department table, and in the same way the value 23 also matches with the primary key column DEP code of the department table. From here we can now conclude that both these tables maintains referential integrity. The previous tables did not maintain referential integrity. This is because for the value 24 under the foreign key column DEP code of the child table doctor, there is no matching value under the primary key column DEP code of the parent table department. But here, all the values for the foreign key column DEP code of the child table doctor are present under the primary key column DEP code of the parent table department. So it maintains referential integrity. Now just have a look at this slide. Okay, read this text and refer the table for a while. Now read this text in this slide and refer both these tables. Now with this, I end my presentation today. In my next presentation, I shall be discussing about the different types of constraints.